Okay, we're going to work on number 2 on the sample final. This is a redox reaction. It's acidic conditions, and the first step is to balance your non-O's and H's. In this case, you got one Cl on the left side, one Cl on the right side. You've got one Cr on the left side, one Cr on the right side. So our non-O's and H's are balanced. The next step is to assign your oxidation numbers. Cl minus 1 is minus 1. O is negative 2. There's 4 of them here. That means negative 8's coming from O. The whole thing's negative 2, so Cr has to be plus 6. Over here, H is just plus 1s by itself. O is negative 2. H is plus 1. So Cl is going to be plus 1. Cr is simply plus 3 since it's by itself as an ion. O negative 2. H plus 1. Next step is draw our line to see which ones are changing. Cl is going from minus 1 to plus 1. Cr is going from plus 6 to plus 3. From minus 1 to plus 1 for Cl, that's going to lose 2 electrons. And from Cr plus 6 to plus 3, you're going to gain 3 electrons. We want to make those two equal or not, so we're going to multiply this top guy by 3 to get 6, and the bottom by 2 to get 6. Remember, this coefficient, the ones you multiply now become coefficients for the species that the arrow is connecting. So we'll rewrite our equation. We're going to have 3 Cl minus plus 2 CrO4 2 minus plus H plus goes to 3 HClO plus 2 Cr3 plus, and then our H2O is the same. Next step, we want to balance our O's since this is acidic. So over here we're going to look, we have 2 times 4, we have 8 O's. Over here we have 3 O's, we have 3 O's. Now I don't count the waters when I'm balancing because you're going to use water to balance. So we have 8 and 3, we need 5 waters over here to balance it. So now we have our O's balanced. The next step is to balance your H's with H plus. So I'm not going to count the H plus, so over here we have no H's. Over here we have 3 right there, and we have 10 from right there. So we have 13 H's total. Over here we have 0, so we're going to add 13 to that H plus. Let me just erase my numbers here. The last step you want to do is to check your charges. If you've done it right, your charges will balance. If you haven't done it right, your charges won't balance. So you should know if you get these right or wrong. We have 3 negative charges over there. We have 2 times negative 2, so a 4 negative, and we have 13 positive. So 7 negative, 13 positive, we have 6 positive total. Over here we have nothing from the first species, 2 times plus 3 plus 6. We have nothing from the water. So our charges balance. So we're done. When you get to this last step, if your charges balance, you're done. If they don't balance, something went wrong. If something goes wrong, it's usually involving 1, you're not assigning your oxidation numbers correctly, or 2, you're not multiplying the right coefficient to get your rewritten equation or reaction. Okay, so that's number 2 from the sample final.